everyone, and welcome back to another episode with dear girl Audrey Codner-Gibson from ACG Math Tutoring. So, I worked out my body this morning. Now let's work out our minds. All right, everyone, as normal, I'm going to share my screen so we can get ourselves situated for today. So today, we're going to do part 2 of determining that slope-intercept form, looking at the equations, but this time we're going to look at it numerically as well as verbally. So in order for us to do that, we're going to do those Common Core standards of ACED.1, AREI.3, and AREI.10. So before we get into today's lesson, we're going to look at our exit ticket from last time. So we need to find the equation of the line in slope-intercept form passing through points -4, -3, and -8, -7. And then we're going to graph our line. So we could, if we want to, this is going to be my x1 and my y1, because that's the first point that I see. And this will be my x2 and my y sub 2. So we need to find our slope. So remember, slope-intercept form. We need a slope and we need a y-intercept. So first we have to use our formula for slope. So we got our y2 minus y1 over my x sub 2 minus my x sub 1. So we have -7 for my y sub 1 or sub 2. Then we have minus a -3, okay? So it's not just going to be -3, it's minus a -3 over -8 minus -4. So when you minus a negative, that means this 3 is now going to be positive. So -7 plus 3 gives me -4. And the same thing is going on in my denominator with the 4. So it's -8 plus 4, which gives me a -4. So -4 divided by -4, that gives me 1. So that means I have a slope of 1 over 1. So now I can pick one of those 2 points. So I'm not going to use both of them because we did that already in the previous lesson. So I'm going to pick -4, -3. Might as well pick the first one. So I have my y equals mx plus b. So I'm going to substitute -3 for my y. My 1 is going to be my slope, and -4 is going to be my x, because I need to find my y-intercept, which is my b. So we have -3 equals -4 plus b. So I want to get b by itself. In order for me to do that, I need to get rid of my -4. So I'm going to do the inverse, which is add 4. So they cancel out. So now I got -3 plus 4, which gives me 1. So it looks like my equation is going to be y equals 1x plus 1. Or I can say y equals x plus 1, because the 1 is always assumed to be in front of the x. So now if I plot, I'm going to start in my origin. I got -4, -3, which is right here. And then I have -8, -7, which is right here. And if I wanted to find that slope, it's going to go up 1 over 1. So there would be a point here, up 1 over 1, up 1 over 1, up 1 over 1. Awesome. So it basically stays right in line with everything. And there seems to be a delay. Okay. There seemed to be a delay on my end, which is fine. So if we can get an idea, my slope is going to be increasing. When I read it from left to right, it's going to be going upwards. So that was last time. So this time, you should be saying to yourself, I can determine the slope and y-intercept in the equation of a line numerically and verbally by the end of this lesson. So right now, we're going to look at our guided notes and some examples, do some practice, and then, of course, we're going to close it out with an exit ticket. So let's look at some helpful hints. So numerically is another way of just saying a table of values, okay? So if I can come up here, it's almost like just a regular XY table, okay? They give you some X values, they give you some Y values. So you can find the slope, or another way of saying rate of change, by identifying the pattern of your y's over the pattern of your x's. So you're going to see what is that pattern of your y values and what is that pattern of your x values, and then you're going to make it as a fraction. So the y-intercept is where the x value is 0. And I'm going to show you in a couple examples what I mean. But verbally means word problems. And I know how much everyone loves word problems. Huge heart, broken. Okay, but word problems, it really kind of helps us connect with those real world examples. So the y-intercept is always your starting point. Okay, so it may tell you the initial value, the starting amount in someone's account, the starting number of players at a game. Okay, those are going to be your starting point, your y-intercept. But your rate of change, your slope, is always followed by the word per. So 5 miles per hour. That means that 5 is going to be your slope. That's going to be your rate of change because it's miles per hour. Okay? So if I look at my example, I have Sheila here. So Sheila earns a base pay of $15 plus $5 per item she sells. So the 15 is what she gets just by showing up for work. But the $5 is how much she earns additionally for every item that she sells. Okay? So the 15 is going to be my y-intercept, and my 5 is going to be my slope. So if I wanted to write the equation, I can say y equals 5x plus 15. Okay? We're going to talk a little bit more about that today. So let's look at a couple examples numerically. Okay? So we got hours and pay. So my hours, that's going to be my x value. Okay? My pay is going to be my y values. The reason why the pay is going to be my y values, this is also known as my dependent variables. So dependent variables is just like how it says, it depends on something. So the amount of pay that a person gets depends on how many hours that a person works. So since hours has no time for anything, let's put it this way. And if we could sit here and I'll just let this video keep going, time keeps going. But what I do during that time value depends on how long I want the video to be. So this is also called my independent variable. All right, so what we're trying to do is find the slope. So the finding of slope is what is the pattern of my y's. So I like to use the word delta. Okay, so I'm looking at slope as the change of my y's, which means delta, over the change of my x's. So I'm taking a look. What's going on with my y values? One, is it increasing or decreasing? Hopefully you're saying it's increasing because I'm going from 15 to 20 to 25 to 30 to 35 to 40. So it seems like it's increasing by 5. So I'm going to write plus 5 here. But what's going on with my x values? If I look at my x values, they're also increasing. But from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So they're going up by 1. So guess what? My slope is the change of my y's, which is a positive 5 because it's increasing, and over the change of my x's, which is a positive 1 because it's increasing by 1. So my slope is 5 over 1. If I wanted to simplify that even further, it's just going to be 5 because what's 5 divided by 1? 5. So now we found our slope. Now we need our y-intercept. So if we take a look, it's wherever my x value is 0. So for this example, would be like if a person didn't work at all. It's almost like Sheila. Just by showing up to work, she's getting paid $15. But she gets paid $5 for every item that she sells. So if I was looking at it instead of how many items she sells, let's say that she's earning $5 additional per hour. Okay, so that means after the first hour, she made an additional $5. So with the 15 for just showing up for work, plus the $5 that she did for 1 hour of work, she'd get paid $20. Hopefully the work is not so intense because seriously, $5? Okay, all right. So my y-intercept is always where my x-axis or my x values is equal to 0. So my y-intercept, my b, is actually 15. So now if I put it all together, I got my y equals my 5x plus 15. This equation is going to represent this particular situation. Okay? So now let's take a look at the next one. So we have hours and miles this time. But let's take a look. What's going on with the pattern of my miles? Is it increasing or decreasing? Hopefully it's saying decreasing. But decreasing by how much? So from 45 to 36, that's 9. From 36 to 27, that's also subtracting 9. 27 to 18, subtracting 9. 18 to 9, subtracting 9. 9 to 0, subtracting 9. Okay? So the pattern is going down by 9s. But look at my hours. What's going on with my hours? Is it increasing or decreasing? So from 3 to 7, that's going up by 4. So that's a positive 4. From 7 to 11, that's also a positive 4. From 11 to 15, that's plus 4. From 15 to 19, plus 4. And 19 to 23, that's also plus 4. So if I'm taking it as my slope, so remember, it's the pattern of your y's over the pattern of your x's. So the pattern of my y's is a negative 9. The pattern of my x's is a positive 4. So in this case, my slope is a negative 9/4. And can I reduce 9/4? No, because the only thing they have in common is 1. So guess what? I have a fraction as a slope. It's okay. You can have a fraction for your slope. Now that you found the slope, now we need to find the y-intercept. As you notice, our x values, we don't see a 0, just like how we did for the other one. But there is a 0 for the y. That's not what we're looking for. We're looking for when the x is equal to 0, okay, to find the y-intercept. So what we could do is we can pick one of these points, just like how we did from last time, and plug it into our equation. So if I go with my y equals mx plus b, in this case, I'm going to use my negative 9/4 as my slope. We're going to substitute in for the x and y values so we can find our y-intercept. So I'm going to try the 23 and 0. Why not? So that means my y value is 0, and we have 23 as my x value. So when we do this, we'll have 0 equals, and since you're multiplying a whole number with a fraction, we can make this whole number over 1, and then we're going to multiply 9 and 23. So let me take it over here. So we got 23 times 9. And yes, it will be a negative number because this is positive and this is negative. So how many 3 times 9 gives me 27. 18, because 2 times 9 gives me 18, plus 2 gives me 20. So we have a negative 207, over 4. So you're probably saying, well, can we reduce that? I'm like, you probably can to give you a decimal, and that's perfectly fine. So let's take it over here. 207. So how many 4s can go into 2? None. How many 4s can go into 20? 5 of them. And then I bring down my 7. So how many 4s can get to close to 7? 1. So I got a remainder of 3. So we could say 51 and 3/4, or we can add zeros to make them as decimals. So this will be 30. So we put our decimal up top there. How many 4s can go into 30? I want to say 7, because that gives me 28. And this will give me a remainder of 2. So another 0, bring that 0 down. So that gives me 5, gives me right back to our 20s again. So we're looking at 0 equals negative 51.75 plus b. Okay, so now I have to add the 51/7500ths on both sides. So that means my y-intercept is actually going to be 51.75. So my equation for all of this is going to be y equals my slope, which is negative 9/4, x plus 51/75. So in a way, if I think of this, miles or hours per miles or miles per hour, starting at 0 hours, we're looking at the person probably started like 51.75 miles away from wherever they needed to get to. All right. So you're probably like, I'm not sure about this, Ms. Codner-Gibson. What just happened? So we can go through it step by step. All right. So don't forget that we have previous examples of this dealing with multiplying fractions and whole numbers. So you might want to review those again, and then we're going to check it out. All right. So now that's basically numerically looking at a table. So now we're going to look at it verbally. So we have a candle that's 6 inches tall and burns at a rate of 1/2 an inch per hour. Write a linear equation in slope-intercept form to model the situation. So we got to think, where are they starting with? How tall is the candle before it was lit? So they're telling us it was 6 inches tall. So guess what? That's 6 inches. That's our starting point. So we have my y equals mx plus b. So my b in this case is going to be 6. But then we burn at a rate of 1/2 inch per hour. Now, if x is going to represent my hours, and y is probably going to represent the height of the candle after it's burned, it's burning. So is it growing or is it decreasing and shrinking? If its candle is burning, it's usually going downwards, okay? So if anything is going down, would that be positive or negative? In this case, it's going to be negative. So negative 1/2 is the rate at which your candle is burning. So the equation is just simply this. Y equals negative 1/2 x plus 6. Or if you want to think of it this way, you could say y equals 6 plus a negative 1/2 x. Okay? If you like to write it the way that you see it in verbal form, you can. As long as you understand when they say that word per, that number in front, that's going to be your slope. If they say this is how much it starts off with, this is the initial, it's at this height before it burned down, that's going to be your y-intercept. That's it. So now, in 1989, okay, some of you guys probably weren't even a thought, okay, each person in the US consumes an average of 133 pounds of natural sweeteners. The amount of natural sweeteners consumed has increased by an average of 2.6 pounds per year. Write a linear equation to find the average consumption of natural sweeteners after the year after 1989. So you're probably saying, oh, do I have to do a whole lot of stuff? No. When you look at word problems, here's the key thing. Always look at numbers. What are the numbers that they're giving me? Yes, they're giving me the year. They're telling me when it's starting in 1989. Then they're telling me what's possible years after 1989. So 1989 is not really a huge factor because they start and end with roughly 1989. But what are they saying is happening in 1989? Okay, well, they're talking about this 133 pounds. All right, so 133 pounds, that's how much they started off when they did this research back in 1989. So the 133, that's going to be my starting point, my y-intercept. So we got 133. So now they're saying it's increased by an average of 2.6 pounds per year. Okay, just because of that word per, that sparks a little notion in my mind that, hey, that's got to be my slope. So my 2.6, that's going to be my slope. So just by writing the equation, here you are. You got y equals 2.6x plus 133. That's it. Or if you want to say y equals 133 plus 2.6x. And the reason why it's just a plus and not a plus minus, because they said the word increase. Okay, so if something's increasing, that means it's growing. It's going to be positive. All right. So now let's get a little practice in there. So let me move my face out the way. So we're asking which situation below is modeled by the table. So let's say that this is going to be my x value, this is going to be my y value. So we have 0 through 5, and we have 100, 105, 110, 115, 120, 125. Now, what's the pattern? What's happening? If I look at my y values, it's increasing by 5, right? It hasn't skipped anything, so it definitely has that pattern. If I look at my x's, they're increasing by 1. So we have like a positive slope. So what is starting off with, my y-intercept in this case is going to be 0, 100, because we already know what my x value is, 0. So we take a look. You have $100 and plan to spend $5 each week. You have $100 and plan to save $5 each week. You need $100 for a new MP3 player and plan to save $5 each week. You need $100 for a new MP3 player and plan to spend $5 each week. So 1, let's take a look. For your y's values, we said it's increasing by 5. So I know if it's increasing, I'm not spending it. It's not going out. Like my amount is growing. So that means I'm saving. So anything that says spent is completely eliminated. Okay? So when you see word problems like this, you always want to go with PO. PO means not PO, like I ain't got no money, with the slang to it. PO means process of elimination. We want to kind of eliminate our options. So if I'm looking at it and I know that it's positive, that means I'm saving money. It's almost like this is money that's in the account. So each time, this was probably going to be my weeks, just taking a guess by the options that we have. And this is probably going to be my dollars. And I'm looking at it as it's a saving. So now we got to take a look at my y-intercept. You have $100 and you plan to save $5 each week. That kind of sounds pretty good to me. But let's see what the other option is. You need $100. I need $100? If I am at 0 weeks and I have $100, it's not negative. It's not saying that we didn't talk about anything about an MP3 player. There was no discussion. It's not negative. So it's not like I started off with negative $100 and I'm trying to build up my funds. I was in the positive the whole entire time. So taking a look at that, my answer choice will be B. Okay? I have $100 and I plan to save because it's increasing by 5. So I'm saving that. That's going into my account, $5 each week. So you want to rent a canoe on your camping trip. The rental place has daily rates plus $10 per hour. If you rent a canoe for 3 hours, you will pay $45. Write a linear equation to find the total cost of renting the canoe for H hours, okay? When they give you like things like this, they're telling you what your variables are. So they want you to use H for the hours and C for the total cost. So one of the things that's kind of missing is they told me that there's a daily rate plus $10 per hour. So that per is telling me that, hey, that's my slope. But if I rented a canoe for 3 hours and I paid $45, how much is my daily rate? So let's think of it this way. If it's $10 an hour and I did it for 3 hours, so let's just kind of put it here, and I did it for 3 hours, that means I should have paid $30 just to rent the canoe. But it said I paid $45. So what am I going to do with that 45? That means it's a difference of $15. So difference means what operation? Subtraction. So guess what? That 15 has to be the daily rate. So if I get here, I got my y equals my slope, which is 10x, and it's going to be plus the 15. So if we want to check it, let's go with a table of values. So instead of a x, it should be a h, right? And instead of a y, it should be a c. So this is going to be my h, and this is going to be my c. So if we're saying 15 is going to be my cost, that means we didn't do any rental whatsoever. But if I rent it for 1 hour, that means it's going to be 10 times 1, which gives me 10. And 10 plus 15 gives me 25. So if I do 2 hours, that'll be 10 times 2, which gives me 20. And 20 plus 15 gives me $35. And if I want to do for 3 hours, 10 times 3 gives me 30. And 30 plus 15 gives me 45. And that's what we said we paid for the 3 hours. So this right here, that's our equation. Okay? So sometimes when you look at word problems, you may not need anything. So I can determine the slope of the y-intercept in the equation of the line numerically and verbally. I think we have achieved that goal because we know how to look at the numerically by looking at the patterns of your x and y values. And verbally, it's just basically look for that word per. And if they say you start off with the initial cost, any of that sort, that's going to be your y-intercept. So we already reviewed the exit ticket from last time. We did some guided notes and some examples. We definitely had 2 different practices. So now we're going to look at our exit ticket. So for the exit ticket, this is all I want you to do. Let me get myself out the way. Okay, you're going to create a real-world problem that represents the data from the table and write a linear equation in slope-intercept form to model the situation. Okay, so you're looking at the table 0, 2, 4, 6, 8, 25, 31, 37, 43, and 49. So you're going to look at the pattern of those and then come up with a fun little word problem. So that problem, you know, person went to work, hours per pay, or hours per mile, or whatever you want to do, okay? Just be creative in that point. But the last part, I definitely want you to get that linear equation. You don't have to go into a full dissertation about what the real world part is. Just make it fun, okay? Just so we can jazz it up a bit, okay? As always, this was awesome. You know, hopefully you guys are getting it. You seem like you're understanding the whole rate of change thing, which is great because a lot of people generally have a problem with trying to find slope. Don't know why. Okay, but also trying to get that translation from verbal to algebraic, that is huge and challenging. So if you were able to do it, good job and kudos. But if you still need more practice with it, that's fine. You can rewind the tape and then come back to it. everything's great. You know, everything's gravy. So we're going to get it all done. All right. So as normal, this has been a joy for me. Thank you so much for participating. And thank you for turning in assignments and giving me questions. And if you ever need anything, please don't forget to like. Don't forget to subscribe. You know, we got a little fun here. And you know what? Don't forget to share. And if you have any other questions, please don't hesitate to contact me. And like always, it's always been a joy. And hopefully you guys are doing all right. And I will talk with you guys next time. Take care.